Good evening, everybody. I am Jack Long, the Mad Scientist, and in this video I'd like to address one of the common questions I have with edgebanders. Has to do with premills. Do you need one? Do you not need one? What's the pros? What's the cons? So with that being said, let's jump into it. Alright, so on your premills, the functionality of a premill is to take a edge, regardless what the edge is, and then dress it back down to a finer, more consistent profile. And there's basically two styles of premills that's currently being produced. One uses reference shoes that chases the edge of the panel down through here, and the other is a unit that does not chase the panel, but actually takes the trimmers, jumps the trimmers into a given position. So this particular machine that I'm working on today has the shoes, and I'll take you over in just a moment, show you a picture of that. But in general, what happens, just so you have an idea of what's going on, you will see that I've got two cutter heads, and the cutter heads themselves are orientated in opposite directions. This particular machine uses a chevron profile, so that as the profile is being cut, it compresses towards the center of the panel. And they do that because that's just the way that BSE prefers to do it. The other common way is that instead of having a chevron that meets in the middle, as the bottom profile here, I'll try not to touch this because these things are sharp. The bottom profile here is a compression cutter, just like you would typically see on a router bit or something like that, and then all the other profiles are down shear, so it's compressing always into your substrate. So as you're cutting your substrates down through here, you're always forcing in away from your surface, and that gives you a significantly better finish. In addition to that, the shear angle that's in here, this shear angle here, causes the cutter to be much more efficient. So it's an energy savings as well. And okay, the units that use a chevron profile like we have here will constantly move the trimmer up and down so that it stays lined with the center of your panel. The units that have just a compression cutter on the bottom, it's pretty much always fixed in the vertical position. It's just a different philosophy for one manufacturer and another. I have advantages on both, and I have disadvantages for both. So you'll see here, see this shoe right here, and here's my cutter, here's my second cutter, and here's my shoe, and you notice the two cutters are in opposite orientations. When you have reference shoes, this cutter cuts, in this instance is cutting against the shoe, and then this cutter over here is cutting against the shoe this way. Every machine that uses shoes, they are orientated in this orientation. So this shoe and this cutter cuts the front of the board, which we'll cover here in just a moment. This trimmer and this shoe references the tail of the board. Differences are, so if we take a look at these heads that's in here, you notice you can see straight through to the cutter head, and that they still have that chevron pattern that's in them that BSE likes to use. And I can get it where the light is not blinding you. So you can see that they just jump into a dead stop, and regardless where the edge of the panel is or anything like that. All right. So sorry about that little distraction, but I wanted to kind of show you what we have in there. So if I am feeding this part, and right now I'm standing backwards to the machine, so if I was introduced this part, I would be feeding the part in this direction, which means that this is the front of my board, this is the head, this is my head, this is my tail, okay? And the shoe that we've seen over there, the shoe and the cutter, it was on the left hand side, it is going to cut a majority of the parts from the lead edge of your panel, from the head all the way through to, generically speaking, 50 millimeters from the tail. Okay, and these numbers, while I'm speaking in generalities, It's pretty much standard across the industry. They'll go to vary a little bit, and depending on who you talk to, you might get some arguments back and forth to say, hey, we're running a little bit closer here, we're running a little bit wider here. That's kind of specific to the manufacturer, and if they tell you differently, just listen to them because they know the machines better. Okay, but in this cutter that we would have here is going to cut a majority of this part all the way up to the end, and then it's going to jump out. All right. The tail cutter is then going to come in, generically speaking, 100 millimeters from the tail, and it's going to come across and it's going to cut the back. Now you'll see here that I have these two drawn in two different planes, and I did that just for clarity for my doodling here, okay, because it's kind of hard to draw and represent this well on camera. So in the machines that have shoes, these two cutter heads in their rotation, this is actually backwards, and they would be in this orientation like this. So as the panel is introduced, that shoe that we would have out here, let me draw you a nice little picture here, see if we can see this. Can we see this over here? I'm not sure if we can or not. But we have a little shoe, and on this back one over here, we would have representation of a little shoe. Let's see, can we see that? I think we can see that. All right, so what would happen is the offset between the face of my shoe here and the apex of my cutter is the depth of cut of the material that I would be removing. So if I was going to be taking off 0.5 millimeter, 3 millimeters, or 2, or whatever you choose to remove off the quantity, that is the offset between the difference of the face of my shoe and the apex of my cutter. And again, I'm trying not to get cut on this, so I'm just going to point at the apex of my cutter here. Alright, then the tail trimmer, this shoe and the apex of my cutter are in 100% exactly the same plane. So what happens is, as you're cutting, we make a decision how much we're going to take off. And let's say, for argument's sake and for the demonstration purposes, we're going to take off 3 millimeters. So I bring this shoe that I have back here, and I bring this shoe back 3 millimeters. So this cutter is proud of my shoe, 3 millimeters, and then as the board is introduced into the machine, the trimmer is either told at this point to come in and be in position, or it's already waiting. It depends on the logic of the machine and who built it. There's really, like everything else, it's not really a right way, it's not a wrong way. It's all kind of manufacturer specific. But nonetheless, this trimmer is waiting for the head of the board to come through. In a lot of the machines that I've done, the shoe will come in and it'll actually jump in and make contact as the board gets here, so that the trimmer doesn't have to travel and wait and get forced back out. A couple things like that. But again, that's manufacturer specific, and you know, it's kind of irrelevant to the discussion. All right. So what will happen is this trimmer has now come in. It's jumped in. Shoe. Now we're chasing the edge of the board, and we are feeding through here. We're feeding through, feeding, and we jump out about 2 inches, 50 millimeters from the tail. And there's several reasons for that, but on the machines that have shoes, part of that reason is that you don't want your shoe back here to fall off the tail of your part. So, you know, that if the apex of your shoe to the center line of your trimmer is 40 millimeters, then you need to at least jump off at 50 to make sure that you're still referencing the shoe. Otherwise, it'll fall off of this, and this cutter head will jump in. And when that jumps in like that, then of course it destroys the part. All right. So what it does, like I said, comes through here, cuts to the depth of cut we chose, and then jumps out. Then, as the machine is continuing to run, the tail of the board comes through, and then at some point the tail is then told to jump in, come in, make contact with this, and come across. And this apex face of this shoe here is now referencing the edge that was produced by this cutter, which is why these two had to be in 100% the exact same plane. So that when this cutter comes in and lands and it starts to make its cut, that these two pass each other, and when you're looking at this cut and you're looking at this cut, you cannot tell the difference between the two, short of the that little telltale sign when you cut wood and the wood fibers kind of lay over and you got a different reflection off the light. It gives you a little shadow. That's the only thing you should see, but you should not see any variances in the actual dimension of the part. All right. Now, when I was telling you on this that we're going to generically jump in about 100 millimeters or so in, that's kind of a target number, because a lot of your machines, whatever your minimum size is, let's say our minimum size is 125, but from the face of this shoe, from in here where we're going to reference the board to the apex, if this is 2 inches and this is 125, so 125 minus 50 is going to give us 75. So just like we would fall off the end here, it's possible we could jump in too soon and the head of my board on a narrow part could catch here on this shoe and cause your shoe to do this. It will cause your board to spin. So when that happens, it creates havoc here. All right, we lose our part. It's a bad day. All right, so that is one of the disadvantages to having shoes, is you need this distance that's in here is much more critical to make sure all these things are correct. Let's see, so in that, like I said, we're going to have this little area where these two overlap. In this overlap, part of the thing that you will see, that you see a lot, regardless if it's got shoes or it doesn't have shoes, is the plunge speed of the cutters, both the plunge and the extraction. So you want them to move at a correct speed, and if they move too quick, what happens is that you can set a vibration up in the machine. So if this one was to jump in, for instance, and it jumped too fast, then you can actually set up a little vibration in this head. It's kind of hard to do and not shake everything, but it will cause a little divot. So when this comes in and lands, it will do this. It'll create a little divot in it, and then when the machine becomes stable, it creates a divot that shows up in your banding, in your finished product. Okay? So when we are considering speeds of pneumatics, in this case it would be a pneumatic jump. When we consider speeds of our pneumatics, we need to have enough pressure, air pressure, at a given flow rate. So one thing that you can do is back down the actual air pressure at a given flow, or we can restrict the flow at a given pressure. So we have two different mindsets, and we have to evaluate that on a case-by-case basis to see which is our actual problem. All right, now that is how a machine that uses shoes, that's how it works, that's how it thinks, and that's again pretty much standard across the industry. The one, as I said over there when we were looking at the machine, the in-feed shoe that we have over here is always going to be a rotation where the cutter, the front trimmer, head trimmer, is cutting first. When you eliminate the shoes and you go to a motor that has dead stops, where the trimmer heads just jump in, they have a dead stop, trimmer head jumps in, has a dead stop. You can have these trimmers in either orientation. So some manufacturers will have them so that they are cutting this way, and this one is cutting this way. Some manufacturers will have them cut like this. And it really doesn't matter. There's not an advantage or a disadvantage. It just depends on how they built the machine, because you know every engineer's got their own mindset and they kind of do their own thing. So when you look at one and you're evaluating it for purchase or for service or anything like that, the orientation, whether one's turning clockwise or counterclockwise, is irrelevant to the functionality of the station. All right, just as long as you are paying attention when you're mounting your cutters. That's the big thing. Okay, so on those it does the same thing. Right now I have this. Let's put this in the reverse orientation so that we are cutting this way, and then this one is cutting this way. So now this is going to cut the head of the board, this is going to cut the tail of the board. So as the machine is running, this will come in, it's going to go through and it's going to cut, and then just before the tail of the board, this one is going to jump in, and it's going to cut this last 4 inches while this one is still in place. And then it comes off the end of the board. This one's going to come out. This one is going to finish cutting. It gets to the tail and it jumps out. Okay, so that's one style and one way that some of the machines do it. I could think of a couple brands offhand. I'm not going to name them because I just don't want to. It doesn't matter for this conversation. Other machines will have them in this orientation, and they act just like the functionality, just like if they had shoes on them, where this was going to come in, cut the head of the board till it gets to the spot. This is going to jump out, and as the tail goes through, this one jumps in and finishes it. Right? Like I said, doesn't really matter. There's not a right way, not a wrong way. It just depends on how they engineered the machine. Justification for premills. Do you want one? Do you not want one? For me, if it was in my shop, I would like to have one because it will go through and it will dress up your edges here, and it will bring them back to 90 degrees, assuming that you have a station that is correct to begin with, properly tuned and everything like that. And if I have a little bit of chip out, which this panel does not, they cut this on a panel saw, and the scoring blade is set correct, things like that. But sometimes the scoring blades, what happens when you look at your scoring blade, this is the edge of my part. Here's my edge of my panel. The scoring blade will leave a little bit of a lip here, just a little bit, because a lot of scoring blades are conical shaped. Then when you go to run it through your glue system, this little gap here creates a less than desirable finish. And if you, depending on how you have your premill set up and how much you're removing, it goes through, cuts that off, you have a nice pretty edge. Okay, that gets back into your panel saw and what you're producing it on, things like that. But this is a possible solution to a lot of problems. If you're using a slider, you have problems with the scoring device on the slider, the tracking of the slider saw, or horizontal panel saw, or if you're cutting stuff on a table saw, you know, there's many reasons why coming through and cutting this would help us. In addition to that, sometimes you will get blade deflection. So when this is the edge of my board, my blade comes through, and I'm going to draw this as an exaggeration. This is my panel, and I don't have a square edge here. This edge is not square. When it goes in and meets the premills cut it off square. Now, you may argue with me, and I do have this argument quite a bit with people, that their saws are square. And the question is how square? What you need to be aware of, and we've discussed this, and I've discussed this at length many times, is that your spindle applies a glue line that ideally is 0.1 millimeters thick, which is 0.004 of an inch, which is a little bit over the thickness of a sheet of paper. That spindle is rated at that precision level up to about 60 millimeters. That's kind of a generic, kind of trying to write this sideways, 60 millimeters. This is kind of a generic industry standard. I've had some that was 120, I think, or it was 100. Sorry. So 50 is 2 inches, a little under 2, and so, you know, basically over 2 inches. They have very small variances between this surface and this surface in relationship to being square. And so if you set this up and you're cutting something on one of your other machines, and the other machines are not dead on perfectly true, then it will show up in your glue pot, because your glue pot will apply glue at different thicknesses. And then when you press in your edge product, whatever it is, if it's half mil plastic or plastic laminate or what have you, if I've got a taper to this, and I'll draw this exaggerated again, what will happen is the part that contacts your spindle will have a heavy glue line, and then your glue line will taper off as it goes. And then when you apply your edge product, now your edge product is following your glue line. Then when it goes into your top and bottom trimmers, which are again tuned to being square, the vertical surface being square and plumb, your tracer wheels and your copy shoes or copy wheels will give you a bad edge. Okay, so those are a couple things to consider. Now back to the people who do CNCs. People who do CNCs, they are not wrong when they say that these edges are pretty pristine. But what happens is, when part of the reason that they go through and they buy CNCs is because they do nested based productions, and that way they get a much higher yield out of their substrates, because the material cost is getting to be substantial. And part of that is you may get a better yield if you use bigger material. You may find that you get a better yield if you use smaller material. Instead of, say, a 5x12, maybe a 4x8 is the correct one to get a better yield. That is not in the realms of what we're going to discuss here. What I want to discuss here will be the chip load from your router and your bit size versus your feed rate. And let's say, for instance, that you get a better yield that makes a decision for the owner, administrator, who that person is, to make a command decision to go from a 1/2-inch router bit to a 1/4-inch router bit. And that change adds up into whether or not they get a high, let's say an 80% efficiency out of a sheet stock, or they get a 90% efficiency out of a sheet stock, purely because they changed their bits. I have had customers in the past that this little change here on one sheet is not a big deal, but when you start doing sheet after sheet after sheet and you're buying bunks, at the end of the year, that's a lot of money. So they make a decision that, yes, we're going to go do this. So what you have to be aware of is that the feed rate, the dust extraction, and you'd be better to speak with a CNC technician or tooling guy on this, because personally I don't play with those machines. I find them boring, so I don't go over and play with them. But what happens is that if we were looking at the chip load, for instance, because the gap that's produced by the 1/2-inch is bigger than the 1/4-inch, you can extract your dust better. Okay, that's one thing. So what that plays into our edge banders is that sometimes you can impact the side of your core in here, and we'll go look at these things, and they have sawdust impacted in the side of them, because as the router is going by, they're not getting the dust out, and it contaminates the side. All right, so that's one thing to consider, because it doesn't happen often. Honestly, it does not happen often, but it does happen. So when that dust then hits your glue spindle, and your glue spindle is doing its thing, it then pulls that sawdust out of the edge of your board and contaminates your pot. All right, and when you're running a premill across it, the premill cuts all that off and it's gone. All right, so that is one reason. Not the only reason. It's not a deciding factor, but it's a contributing factor. In addition to that is when you start to impact these bits with the ability to extract dust, the bit actually starts to load up, and you'll get a little bit of bit deflection. And I can't say how much, because again, I'm not an NC tech. They would be better to talk to about that. But the biggest factor that I see when you make this switch is that when your axes on a CNC, when the head is making a cut down through here, and it's running at its given speed, when it starts to make the corner down to here, it starts to ramp down, so it goes slower as it makes its transition. Then when it turns around, it does an acceleration, and it's accelerating as it goes through here till it gets up whatever its maximum speed is, and it slows down again. And when you start to get into these smaller bits, you will get a very minor amount of bit deflection side to side as this is speeding up and slowing down. And it's minor. I'm going to, credit to the CNC guys. They do know their crap. They do, between them and the tooling guys, they got this down to a science. So when they tell you what your feed rates are, this and that and the other, but what happens is part of our education process that we have to do is that the administrators and the bosses that want all this stuff done, and they're bidding everything, and they say, I've got to have this many parts, this many, going through the machine to make everything profitable based on the bid to the customer, is they expect that CNC to just run balls out. And sometimes faster is not the solution. Sometimes you have to slow down to go better. So when you get that kind of mindset, and I can't blame them for it, it's just a reality. When you get that kind of mindset, then what happens is you get some bit deflection coming off of this, and if you don't have a premill, it shows up in the glue pot, and it goes back to this, and you will have, it will go anywhere from a little bit of an angle back to square, and back to an angle, back to square, as it's ramping up and slowing down, and it will make you bat crap crazy. All right, so again, is it a deciding factor? Maybe, maybe not. Is it a contributing factor? Absolutely. Whether you choose to go that way, it's up to you, as long as you're aware it's there. All right, and again, kudos back to the tooling and the CNC guys. They know their stuff. So when you start describing this stuff to them, they're better to advise you on it than me. I just know that it exists. All right. Then the last thing is the availability of premill machines. When I started as an operator, going back 30, what year is this? 24. I started in 89 as an operator. My first experience with one, and 89, 90, somewhere. Anyway, so 34, 35, 36 years ago, whatever the math is, I don't know, math is hard. Premills were out there. They were not prominent because the big boys could afford them, could justify them, but we were a smaller facility, and it was a cost that the owner chose not to spend. And as the machines have aged and the 3mm plastic product and everything start to become more prominent, premills, they're much more seen in the field now than they once were. At one point, premills were an oddity, and now it's more of an oddity to not have one. Okay, so with that in mind, the reason why I'm saying all that is at some point, hopefully, you will be selling this machine and upgrading, unless it's your once-in-a-lifetime machine. But at some point, you're going to want to resell this machine. And at what point in the market is that premill going to make your machine marketable? If the next customer is looking for your class of machine and they need a premill and yours does not, then you're going to get yourself eliminated from a potential location for your old machine. It may be a deal breaker, it may not be, but keep that in mind. All right, the last thing about premills, and I promise you this is the last thing. On premills, when you go to these shows and the dealer at the show, or you're going to a showroom or a manufacturer, whoever it is, that when you're going to look at these machines, you have that new car enthusiasm. You know, you're excited. You want to see this, you want to see this, you want to see this. And the dealers are there to present their machine, sell you their machine. They say what is more than likely the honest truth from their point of view for their machines, and you hear more than likely what you want to hear, because that's why we're there. We all got that excitement, right? So a lot of times you get out in these machines and there is a miscommunication. The dealer says something that's a little, it's not wrong, they're not lying to you, but as a purchaser, we hear what we want to hear. And one of the things that they tell you is that the advantage of having a premill is that you can go through and reband your material, and the quality of the banding afterwards is just as good as before. And that is not necessarily correct, but it is absolutely not necessarily wrong. One of the things that operators or customers hear is that if I band this edge and this edge is bad, that I can just take this back to the beginning of the machine and take that band off, and the premills will eat that band off. That is the miscommunication. You can do that. You should not do that. The diamond tooling, and where did my diamond tool go? Let me find my diamond tool. The diamond tooling is extremely hard. It's also extremely sharp. And the trade-off on those two is because it is this the one that's damaged? No, this one's not damaged. The trade-off is that since it's so sharp, you get a much longer tool life. But since it's much more brittle, you're more likely to damage the cutter. Let me get my pointer. Here it is. Can you see how boogered up this tooth is? How boogered up this tooth is? It's got a nice big chip in it. This chip that's here is because they ran plastic laminate over and over and over, and it just wore out. It's just a dull spot in the knife. But this one, something actually hit it. In addition to that, the one next to it that I just wiped my finger on, there you can see it really well. Can you see that there? How damaged that is? Something hit that. So instead of being like a carbide where you might knock a little bit of your edge off and it just, it gets more dull quicker, diamond explodes. It just breaks, chips, gone. This tooth here is now completely worthless. So if you have plastic laminate on this, for instance, or 3mm PVC or 1/2 mm PVC, when you send that back through and that hard product hits this diamond is toast. And it may not do it in a single foot, a single foot piece like this long, but if you do this in, it may fail in 20 feet, or it may fail in 30 feet, or 60 feet, or whatever that winds up being. So the loss in tool life and the damage to the cutter head is significantly less. So when you hear these dealers at the shows and they tell you you can rerun an edge, they are not necessarily lying, but you're not necessarily hearing exactly what's being said. So what you do is, when we set these machines up, we have our in-feed fence, and then we have, we'll call it 0 on your cutter heads, so that when the fence is turned off and put at 0 and your cutter head is cutting 0, then what happens is we're actually cutting off about 0.1. Now this 0.1, as we're going through the machines, you'll notice that this 0.1 pops up a lot. In this particular case, this 0.1 happens to be the thickness of my desired glue line that I strive to achieve. So what happens at that point is I get a bad edge, and maybe I'm one of the guys that has the hot knife table that I can lay the edge down on that hot knife table and warm the edge up so the banding just delaminates, pulls off. But a lot of shops don't, so they go in and they do that destructive test. They just grab a hold of it, rip it off. When they do, there's always residue left behind on this edge. And then when you set this up for 0.1 and all you're doing is doing a dust cut across this outside edge, you're pulling off that glue. And most of the time, if everything in your Edgebander is set up, which hopefully it is, but if everything is set up correctly in your Edgebander, while you are taking off a little bit of material, it should not change the dimension of your finished product enough that quality control will reject the part. Okay, so I hope that long dissertation explains to you why you would want a premill, or maybe why you don't want a premill. If I had a conversation with a customer, I would be asking them all kinds of questions about what they're doing, what their desired product is, if they were doing veneers versus MDFs versus particle board or plywood core. All of this comes into play with it. So when somebody says, hey, all my colleagues out there, do I need a premill or not? It is not that easy of a question. You have to kind of stop, sit, and do your thinking about it. Some shops, it's worth it. Some shops, it's not worth it. If you are more concerned with time than money, quality than money, yes, buy one. But if money is a concern, a big concern, then don't buy one. Because they're expensive to run, they're expensive to put on, but you do get a superior finished product. Okay? Now, I want to preface that when I talk about money, is back when I had my own shop, I didn't have money. My Edgebander was a clothes iron, so I empathize with people where money is a concern. Just in full disclosure. Alright? Alright, so last thing on premills, at least for this video, is the quantity of the material being taken off. So there is always a discussion between the technician, the operator, and management as far as how much material you take off. And there is a philosophy, and I have another video I was going through and teaching a technician course earlier this week that I have posted out somewhere. I don't know if I've got it uploaded or not, but the 3 key understandings for the machine with your reference zero, your unipoint, and your preload tension. Right now I am not going to go into those other than to explain your reference zero, touch on it. So what we are doing is that we've got a board and we're running it through and we are cutting a given quantity of material off, applying the glue, and then added an edge product back onto it. So a philosophy is that you set the fence up to a given number and you always take off that amount. Let's say 5 thousandths, which is 0.1. That would be 0.12 to be exact, but let's say you're taking off 5 thousandths or 10 thousandths, or you're taking off a half a mil, or what have you. Whatever that number is, you're always taking that off, and then when the material is being sent over to you somewhere in your cut list, providing material to this machine, that quota is being calculated. And that way when your material comes to you, that it's already calculated into it. Then that way when you when you do have a part that has to be re-ran, you come back over and you put your fence at 0, so it's taking off 0 material, and you repass that part to the machine and it comes out the correct dimension. So that's one school of thought. A second school of thought is that you set it up so it's just barely taking anything off, like 0.1 millimeters. And again, the part dimension that's here is calculated prior to arriving here, so that when it goes out the tail of the machine, that the part is finished at the correct dimension. Then there is the school of thought that you take off and put on whatever it is, you take off and apply the same dimension. So if I'm putting on a half mil banding, I take off a half mil. If I'm putting on 1.6 plastic laminate, horizontal grade. Sorry, it's been a while since I did plastic laminate. When you put on horizontal grade plastic laminate, that thickness you take it off. If you're doing 3.0 wood, you put on 3.0. If you're taking off 3.0 plastic, then you pre-mill off 3.0. I think I said that wrong, but you know what I'm getting at. So you're cutting net size. All right. If you're starting to do solid wood, solid rims, greater than 3 millimeters, that's kind of the cutoff for what pre-mills are designed to take off. Okay. The motors tend to be optimized around net. Some machines, if you go in and look at the specifications for the machines, they can take off a full 3 millimeter depth, but only up to a certain height. Let's say 25 millimeters, for instance, because a majority of what the customer is going to run is going to be thinner stuff, and they do that to save money. And the manufacturer saves money, customer saves money, customer gets a better machine because they don't need to pay for the oomph that it takes to cut 3 millimeters across 60 millimeters tall. This particular machine, this has got a really, really heavy, I think it's a 4 kilowatt motor. Could be wrong on that, could be 2.5. It's been a while since I've been in and checked it. Anyway, it's a strong motor. All right, so nonetheless, the decision of how much that we're taking off has to be a decision and a conversation that's had with management so that you can find out if you're going to take off 0.1, 0.2, 0.5, taking off what you add on, or whatever that quantity is. A lot of the modern day software that you're designing your cabinets with now have fields where you can go in and automatically make those changes. And I'm not going to tell you that I know how all that works because I don't deal with that side of it. I just know that they can send that quota out and it can offset your machines, your CNCs and your panel saws, so that the panel dimension as it arrives here, if the communication between the office, the CNC operators, panel saw operators, and the Edgebander operator, if we're all on the same page, when it comes out the tail end of the machine back there, it's the correct dimension, okay? I have been also, just keep this in the back of your head, I have been in facilities, and fortunately, as we've had conversations before about the availability of premills, is that some facilities still run machines without premills. And when you go get a premill, you don't want to set the premill up to cut 3 millimeter off if the machine that's right next to it does not cut anything off, because then you wind up having a confusion of parts as they're going through the plant, okay? And that is a conversation that should be held between the technician and your engineering staff, management staff, stuff like that. There, and I don't recall the company's name offhand anymore, but I did one where they had 2 machines that I was installing that had premills. They had 2 older machines that were being retired that did not have premills, and we had to come up with a plan to control inventory as it was going through the plant, so that the new inventory coming in and arriving, that they knew whether or not the inventory was cut dimensionally for a premill machine versus a non-premill machine, until they could go through all their inventory in the plant. And to give you an idea time frame wise, this has got to be back in the early 2000s when the Americans were still doing a lot of the inventory run-up, where they would cut 1,000 pieces of something, or 2,000 pieces. They weren't so much down into the just-in-time kind of mindset as we are now. So it was quite a task for the customer to manage the pieces. Once they got to a certain point and they knew that the material arriving to the machine was one dimension or the other, then they were comfortable enough with the machine, and as it passed through the line, it did not create an inventory problem. But the last thing they wanted was pieces that were milled the wrong size, and it failed for whatever reason. Okay, so in this, what we're trying to decide is when we put the part down, and what we're wanting to see is how far it overhangs the side. Okay, so the overhang of the chain is what we're changing. All right, there are some tricks that you can do. A lot of the machines that have NC axes on the front, when you change the dimension in the software, you can go in there and it will automatically change both the fence and the in-feet shoe, and they automatically calibrate together. Other machines, as this one, has 2 mechanical stops, and it's possible the mechanical stop of the fence could be different than the mechanical stop for the shoe, and you'll get 2 different dimensions when you process a given size. So if I'm supposed to be taking off a 0.5 millimeter, and this is set to compensate for 3/4 millimeter, but the shoe is set to compensate for a 0.5 millimeter, it changes the pass line of the panel as it goes through the machine, and the error, even though it's taken off the right quantity because the shoe is correct, the error will show up down there in your corner end trimmers, because the end trimmers are looking for the pass line that's set up based on the fence and the correct alignment to the shoe. So problems that we have here, the problems we have with the shoe, not only create problems with the glue pot or solutions in the glue pot, it also shows up with problems or solutions in our end trimmers. All right, and even less sophisticated machines, still good, mind you, but less sophisticated, is that they will have hand knobs that you adjust those values. And when you adjust the knob, if the quantity you're taking off at your fence does not match what is taken off at your shoe, then you'll have a misalignment in your panel, and you can make the panel grow or you can make the panel shrink based on changing those numbers around. And that shows up down in, farther down the machine, and it may not be a problem. If you, depending on what it is that you're cutting, you may not care. Okay, so if you're running lineal shelves, for instance, you're doing California closet kind of installation, and you really don't care what the ends are going to do because you're chopping them all up, you could care less. End trimmers are no longer an issue. All right, now from there, we talked about the differences between premills that have shoes and premills that don't have shoes. Premills with have shoes have the issues that we were just talking about. The disc fence and the shoe, they have to equate with each other. They rely on the reliability or the precision setup of each one. If you have a machine that does not have shoes, it no longer cares, because the motors jump into a given spot and then they bottom out, and that's where they go. If it's taken off 3 millimeters with your fence, you take off 3 millimeters back here. If you set it up for 0.5 millimeter, take off 0.5 millimeter. If you take it to just do a dust cut, it's going to do a dust cut. If you set it up where, for whatever reason, you actually move it too far my way and you actually set the fence less than 0, then your premills aren't going to touch anything and you're just wasting electricity. Okay? So, when we were way back at the beginning of this whole discussion, I said they have pros, they have cons. They have pros, they have cons. A pro for the machine not having shoes, the premills without shoes, is that it makes the adjustment for the quantity that you remove, makes it easier to set and maintain, and from an operator standpoint, if you set whatever you set here at your fence is going to be taken off if everything is correct. If it's at 0, nothing's taken off. If it's at 3, 3's taken off. If you have the shoes on your premills and this is set for 3 but your shoes are set for 2, you're only going to take 2 off. Okay, like I said, pros and cons. I like them both. I don't like them both. Doesn't matter to me. All right, if I had a machine, I'd be happy to have a premill. I don't care one way or the other. It really doesn't matter. Okay, so I think that we have gone through everything on the premill that we possibly can go through, short of somebody joining me on site and putting wrenches on a machine. I think that we've gone through everything. I believe so. So, hopefully you like this, you find it informative. If so, you know what to do. Like, subscribe, comment, share it. Help me out. Spread the word. I really appreciate it. Thank you very much. Have a great day. Oh, I forgot one thing. As always, guys, be safe out there, and let's go make $1 million.